So what we're going to look at now is velocity and acceleration. In particular, we will be looking at acceleration. Now, the acceleration is the rate of change of velocity. The rate of something is how it changes with time. So, the acceleration is the change of velocity divided by the time taken. An example. If a car travels from 20 meters per second to 100 meters per second in 4 seconds, what is the acceleration? So the change of velocity, which is from 20 to 100, which is 80, divided by the time taken, which is 4 seconds. So it's going to be 80 divided by 4, which is 20 meters per second every second. Now we're going to look at a velocity time graph. Now in this particular velocity time graph, we can see that the velocity is staying at 10. If the velocity does not change, then there is no acceleration. So we have constant velocity. Now the acceleration is the change of velocity divided by the time that's taken. If the change of velocity is 0, then the acceleration is 0. So it's 10 minus 10, which is 0, divided by 5, which is going to be 0. No acceleration. Now we look at the second graph. Here we can see the velocity is changing because it starts at 0 and goes up to 8. It does this in 4 seconds. Another thing we can see is that for every second it travels faster by 2 meters per second. So the acceleration is 2 meters per second every second. We say 2 meters per second squared. In the second it goes from 2 to 4. Here again, an increase of 2 meters per second in that second. The next second it goes from 4 to 6. Here again, an increase of 2 meters per second. So that's what's happening in that part of the graph. What's happening here? Well, the velocity is staying at 8. And we can tell by looking at this that the acceleration will be 0 because the velocity is not changing. Let's look at this in a bit more detail. Now the acceleration is the rate of change of velocity. The change of velocity divided by the time taken. So it's 8 minus 0 in 4 seconds. So it's 8 divided by 4, which is 2 meters per second every second. The interesting thing here is the acceleration is basically the rise over run, which is basically the gradient. The steeper the gradient, the higher the acceleration. Now here we have an interesting situation. We know that this the velocity is the distance divided by the time. What we can do is try to rearrange this to get the distance. Well, in this equation, to get distance, to isolate distance, we multiply both sides by time. So we end up with the distance is equal to the velocity times by time. Now, that's the velocity, and that's the time. The velocity is 10 meters per second, the time is 5 seconds. But wait a minute, we're just multiplying two sides of a rectangle, which gives us the area. And this is a very useful fact. This is basically 10 times by 5, which is equal to 50 meters. So it's basically the area of a velocity time graph gives us the distance that has travelled. So the distance is the area under the velocity time graph. That needs to be noted. So what is the distance covered here? Well, there are two areas to consider. There's the light blue area on the left hand side, which is the area of a triangle, and then there's the area on the right hand side, which is the dark blue, which is the area of a rectangle. See if you can find out what the total distance travelled in this case. Is the area of the graph. So we basically have to find the area of the triangle, which is a half base times height, half times 4 times by 8, plus the area of the second part, which is going to be 6 times by 8, which gives us a total distance travelled of 16 plus 48, 64 meters. So, as a summary of distance time graphs, and velocity time graphs. What can we tell by looking at a distance time graph? Firstly, for distance time graph, we know that the gradient is equal to the velocity. In this case, as the gradient increases, the velocity must increase too. The second graph is a velocity time graph. What can we find out about that? The gradient is equal to the acceleration. Here, however, the area is also equal to the velocity times time, which is the distance travelled.